So first, let's look at PB1 here. PB1, we already found out the type, if you remember, is normally open type. So that's the PB1. And then let's look at when the push button is released. So right now PB1 is released. And the tag value. So the tag value, if you move to here, you can see the chart, the tag value is 0, right? So normally open is when it's released, tag value is 0. That makes sense. So it's 0 on here, and then we need to draw the green bars on the highlight instruction. Right now PB1 is released, the value is 0. You can see on here the value is 0, and which one has the green bar? Is the exam off over here. So on here we just need to draw the green bar on the exam off. So make a note on this. So when the normally open push button is released, tag value is 0, and normally closed, the exam off instruction has the green bar. Now we want to look at when the button is pressed. So now we press the button. This tag value right now you can see is 0. When I press, that should be 1. We already practiced in the previous lab. And then in the same time, the instruction will change state. So let's do it. So you can see when PB1, when I press and hold the button, I need to hold it because it's momentary button. Right. So when I press and hold it, the exam on has the green bar. Exam off doesn't have that. Alright, so go back to the chart over here, and the value is 1 when it's pressed. And when the value is 1, we found out the exam on has the green bar. Okay, so that's on the PB1. Right. And then let's look at PB2. PB2 we know is different type. It's momentary, but it's normally closed type. It's normally closed. That means when the button is released, like right now, button is released, and the tag value here you can see. Right now I'm pointing to PB2. It tells me this tag value is 1 because it's normally closed. If you don't press it, it's closed, and then PLC will get the input read as 1. So this is what we found out. So over here we write down 1. So this is the tag value different. And we also found out the difference, right? When the PB2 is released, tag value is 1, and exam on has the green bar. So we come over here. I don't know how do we, if I can get rid of this part. Yeah, so over here, exam on has the green bar. Recording. Okay, so this is when the push button is released. Released is the normal state. So now let's try when the button is being pressed. So we press and hold the button. See what happens with the instruction. So right now the tag value is 0. It's 1 because it's normally closed. But when I press, you can imagine the value will change to 0. And same time the instruction will change. Right? Exam on, the green bar disappeared, and the green bar appears on the exam off. Right? So if I release the button, it's gonna go back to the normal state. So over here on the chart, we'll just write down the value is 0, and also we record that the green bar is on the exam off. So this is what we find out the program. So once we get over here, this is what we can get the conclusion on here, right? So if you doesn't matter what type of button or the state. So if you look at over here, whenever the tag value get 0, the exam off become true. It has green bar. Same thing here. Same that happens on PB1 and also happens on PB2. This is what we found out. And whenever the tag value is 1, you can see the key point is the tag value. When tag value is 1, we will see the exam on instruction become true. That's this part. That's what we found, right? So that's the conclusion. Then the tag value is 1, exam on instruction. This instruction is true. If the tag value change to 0, and exam off instruction become true. Right. So this is the conclusion. This is very important, the first step. So how do we choose exam on and exam off instruction? You can see that really depends on the tag value. If the tag value is 0, exam off is true. If the tag value is 1, the exam on become true. It doesn't matter which push button, and also not directly to the type, but really directly related to the tag value. So let's do some exercise on here. First, in order to energize the output, we have to choose the instruction according to the tag value. We now apply this method in the following logic design. We will design two different rounds, two different questions. Right? For question number 1, you can see we want when PB1 is pressed, we want to energize PL1. So that is what we will do with the ladder logic. So how do we analyze this question? First, there are 4 different steps. You can see over here there's step 1, step 2, step 3, step 4. We go through these 4 steps to choose the instruction. I recommend you strictly follow these 4 steps at the beginning. But once you are familiar with these methods, you don't have to write down on the paper. Right? But at the beginning, we can go through these 4 steps one by one. So first step, we need to check the input device type. So the button in the question is PB1. So PB1 we know is normally open, and also that's momentary. So we record that here. So second question we ask to ourselves, the device required state. So in the question we want to see when the button is pressed. So you can see that's pressed. Right. So that means we want the button being pressed, not released. And step 3, the PLC tag value as a result of the state. Actually, because the step 2, right? So we need to decide the tag value. So what we have over here, from step 1 we know it's a normally open push button, and then step 2 tells us we need to press it. So when you press a normally open push button, it becomes closed. PLC will read tag value 1, not 0. And when the tag value is 0, we need to choose exam on. Right? You can imagine 1 is the state of on, so we choose the exam on instruction. So how do we write the ladder logic? So to energize the PL2, we just use output energize, right? And now we choose the input instruction. Because we are on step 4, we are decide that's exam on with PB1 as the tag. So this is what we go through the 4 steps. We find out the solution for question number 1. So now we work on question number 2. Question number 2, we want to see when PB2 is pressed. When that happens, we want to energize PL2. So PB2, remember we already know that's normally closed push button. Right? It's different type compared with PB1. But the same state, we want to have the PB2 being pressed. So over here on step 2, we circle pressed. So with a normally closed push button, when you press it, it becomes open. When it's open, PLC will read the value, tag value as 0. Okay. 0, you can imagine that as represent off, right? So the off state. So in order to get logic true, because tag value is 0, we need to choose exam off instruction, not exam on. So with the ladder logic, OTE, output energize to PL2, same thing as before, but this time we will use exam off with PB2 as a tag. Right. So that is how we design these 2 questions. So when PB1 is pressed, we will see PL1 turn on. When PB2 is pressed, we will see PL2 turn on. So we already have the 2 existing logic, so we need to do online edit. If you remember from lab 1, we did only we practice on the online edit. I will do the demo. So right now we are on the remote run. We are online to modify this program. You can see the first line, run 0. We just need to remove this exam off instruction. So we can double click. Once we double click, we have 2 copies. The top one is the working copy. So we can work on this one, highlight the second instruction and delete. So that's exactly what we want from the design. Now, then we need to finalize. Now that's the instruction we want to have, the logic we want to have. Let's try it. So we press PB1 on the HMI. You can see on the logic, this one, turn it on. And same thing, same time on the HMI, you will see PL1 turn on. So that's exactly what we want. The question is, when PB1 is pressed, PL1 is energized. Okay, we did the first one. So the second round, round number 1, that's our design. We want to keep the exam off, remove the exam on. So now with online edit, double click, highlight exam on, delete, then finalize. Once we finalize, you can see we press PB2 and PL2 turn on. If I release, PB2 turn on.